Hello, everyone, and thank you for attending Lab Manager's Green Labs Digital Summit. My name is Mary Beth DiDonna, and I'll be moderating this discussion. Laboratories use a huge amount of energy, which means high utility bills and a toll on the environment. Labs are joining more and more countries across the globe who are implementing green practices in order to save both money and the planet. Lab managers and lab planners are using innovative techniques to cut back on water usage, increase daylight into dreary research areas, and reduce their waste output. It's important to remember that a more sustainable lab can't be developed overnight. Lab managers should take a look at the small changes they can make now to save time and money down the road. Welcome to this session, Solving Sustainability, a look inside the lab. The most sustainable labs in the world didn't just happen. Out-of-the-box thinking, countless details, endless conversations that began with what if and is it possible led to the most sustainable laboratories in the world. These labs will change the future as we know it. So how do we bottle such innovation to make it repeatable? This session will enable lab managers to learn the roles and responsibilities of key stakeholders, relevant sustainable trends and goals, and discover the assessments for maximizing energy efficiency in order to embed sustainability into your lab and facility plans without compromising innovation or limiting the applications of the lab. Please send us your questions or comments at any point during this presentation. Our speaker will address these questions during the Q&A session following her presentation. To ask a question or leave a comment, simply type your query into the Q&A box located on the right-hand side of your screen. We will try to address as many questions as possible during our time together, but if we run out of time, I will forward any unanswered questions to today's speaker and she can respond to you directly if possible. We also invite our live attendees to participate in our special poll where you can contribute your thoughts for a chance to win a gift card. Additional resources for today's presentation are also located on the right-hand side of your screen in the handouts section. The handouts section includes handouts from our sponsors, as well as more information about our Lab Manager Academy management courses, and also information about Lab Manager's return to live events with our live in-person Leadership Summit on May 16th through 18th in Baltimore, Maryland. I would like to remind you that the recording of this webinar will be available for free on-demand viewing after the conclusion of this event. I would also like to extend a special thank you to our sponsors whose support allows Lab Manager to keep these webinars free of charge for our readers. So with that, I would like to introduce our speaker for this presentation. Ryan Rios has a BA in Marketing and Advertising from the Art Institutes International. She is the Vertical Marketing Manager and co-lead of a Sustainability Committee for Labconco Corporation. She is Stanford certified in sustainable business practices and works with a diverse team of engineers, service, financial, and operational to improve manufacturing processes to optimize the environmental and social impact of business operations. Her certifications, experience, and affiliations include the Stanford Sustainability Certificate, American Marketing Association Certificate, American Advertising Federation of Kansas City, and American Institute of Graphic Artists. Ryan, thanks for joining us today.
Welcome. Thank you for joining me. My name is Ryan Rios, and I am one of the Labconco Sustainability Committee team leads. I'm excited for this discussion with you all on sustainability and its impact on your lab. I would encourage this to be an open dialogue for discussion, so please comment and post your questions throughout our session, and we'll get to those at the end. If you have any follow-up at all, we would love to hear from you. Email our team at sustainability@labconco.com.
What if I told you we could cure an incurable disease, but could harm the ozone layer and cause natural disasters that wreak havoc on at-risk communities the most? Not a fair trade, right? So one study that was developed recently on monoclonal antibody development found that the global warming potential for one US-based 2,000-liter process was shown to be 22.7 tons of CO2 per 1 kilogram of drug substance. This means that each 1 kilogram of potentially life-saving drug substance developed could, on average, have the same annual impact as 4.9 vehicles driven, 2.7 homes energy use, 2.8 million smartphones charged, and 928 propane cylinders for at-home barbecues. Sustainability is becoming an ever more prevalent consideration for lab planners and the scientific community, and it isn't going away. Today, let's define some of the roles and responsibilities of key stakeholders, discuss some of the relevant sustainable trends and goals, and the assessments for maximizing energy efficiency in order to embed sustainability into your lab and facility plans without compromising innovation or limiting the applications of the lab. Sustainable lab planning begins with a clear definition of the roles and responsibilities of the key stakeholders throughout the process. It calls for a high level of communication and for decisions to be understood and evaluated throughout the process by these stakeholders in order to maximize efficiency throughout. The building owner is going to have the ultimate responsibility per OSHA. The owner is responsible for hiring a chemical hygiene officer to perform a risk assessment and develop a chemical hygiene plan, as well as the subsequent enforcement of that plan, as it is specified by the chemical hygiene officer. They establish the need for a project, and they will be responsible for the selection and hiring of the architectural, engineering, and contracting team. The chemical hygiene officer, or authority having jurisdiction, is hired by the owner. They're responsible for conducting a risk assessment in order to define the chemical hygiene plan, which is to be carried out by the owner. They additionally are responsible for the equipment selection criteria as well as the operating parameters. The architect is your primary owner consultant. They are a conduit of information between the safety and design teams. They guide the customer through the risk assessment process. They communicate airflow criteria to the engineer for the purpose of achieving the owner project requirements and/or the chemical hygiene plan. They're going to collaborate closely with the engineering team in order to plan for architectural adjacencies with the specified mechanical system requirements in mind. In efficient lab design, it's going to be key for the engineering team and the architectural team to be communicating throughout. Otherwise, you'll lose opportunities to integrate efficiency. The mechanical engineer is responsible for ensuring that the mechanical system is designed and constructed to deliver the operating parameters specified in the chemical hygiene plan. They're responsible for delivering that safe airflow solution. That includes selecting the mechanical systems, calculating duct sizes, and designing that mechanical system. The general contractor is going to be working closely with the architect throughout the process. They will hire subcontractors and be responsible for things such as building permits and coordinating installation codes review to ensure that everything is to code and to ensure that the production process goes as scheduled and to plan. The manufacturer should be the trusted consultant, specifically for the customer and chemical hygiene officer, to help them understand the chemical hygiene plan and risk assessment. They can assist with the knowledge of codes, laws, best practices, as well as industry trends. More importantly, they are going to assist the design team to convert the risk assessment report into meaningful mechanical system criteria. They will enable the mechanical engineer by assisting on feet per minute to cubic feet per minute tables, minimum air changes per hour to cubic feet per minute tables, knowledge of static pressure loss, as well as just optimizing efficiency in general. This method will engage stakeholders who might be otherwise separated from the design process and will lead to the most sustainable process possible. Now, let's discuss some of the relevance for sustainability. Labs consume a substantial amount of natural resources. Global research, for example, which includes millions of labs, consume 5 to 10 times the energy per square foot than office buildings. Specialty labs, such as clean rooms or labs with large process loads, may consume as much as 100 times the energy of a similar size structure. A single chemical fume hood can use as much energy as 3.5 households every day due to the large volume of air that must be moved through the hood by the ventilation system. In a 2018 study, they found that the global pharmaceutical industry's carbon intensity was 55% higher than the automotive industry in 2015. The 2019 climate footprint of healthcare was 2 gigatons of carbon dioxide equivalent, representing 4.4% of total global emissions, with the majority, 71% of that, derived from the healthcare supply chain. This includes biotech and pharma. Further, the biotechnology market is predicted to grow by 15% each year, and the pharmaceutical market by 11%, reaching $2.44 trillion and $970 billion, respectively, by 2028. In a plastics forum hosted by Cytiva, experts mentioned that the single-use technology is growing every single year at 25+%. Single-use plastics, or SUPs, were invented for the modern throwaway society, and they are intended to be used only once and are produced globally in masses, most notably as packaging or consumables such as SUP bags. SUP wastes leak into the environment, having visible adverse impacts on ecology. There are resources now that turn this hazardous waste into new materials and goods, such as pallets. So please note at the end of the presentation these resources. While we're beginning to see a lot of progress and new techniques being developed, there is a lot of relevance for sustainability in the laboratory, and there are very targeted goals that have been set in order to address them. Let's dive into some of those. The United Nations Sustainable Development Goals, also known as the Global Goals, were adopted by the UN in 2015 as a universal call to action to end poverty, protect the planet, and ensure that by 2030, all people enjoy peace and prosperity. The most relevant for our industry are going to be climate action, clean energy and infrastructure, and clean water. The Paris Climate Agreement's central aim is to strengthen the global response to the threat of climate change by keeping a global temperature rise this century well below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit the temperature increase even further to 1.5 degrees Celsius. Other key influencers in this arena are shown on this slide. Now, the Federal Energy Management Program encourages labs to optimize energy efficiency using a whole building approach rather than specific lab components. Some of the resources they provide include the Smart Labs Toolkit, which is a website that helps operators plan sustainable labs. Climate neutral research campuses includes a planning process and tool to reduce energy use on campuses. The laboratory benchmarking tool compares energy use of lab buildings to that of similar facilities in the United States. The breakthrough outcome for the pharma sector states that 95% of labs across major pharma and medtech companies are to be My Green Lab certified at the green level by 2030. Although, according to an evaluation by Green Labs, we are far from this goal. They break down carbon emissions into 3 different scopes and divide them by direct and indirect emissions. It was found that Scope 3, which includes all other indirect emissions upstream or downstream in a company's value chain, represent more than 85% of the world's overall footprint. So these Scope 3 emissions will be a real area of focus for the pharmaceutical sector moving forward. Now let's discuss the AIA 2030 baseline. The urban built environment is responsible for 75% of our annual global greenhouse gas emissions. Buildings alone account for 39% of that. Eliminating these emissions is going to be key to addressing climate change and meeting Paris Climate Agreement targets. For the past 15 years, we've been making significant efforts. The baseline provides a roadmap to reaching carbon neutral facilities by the year 2030. The challenge sets targeted goals for stepped reduction in 5-year increments, and it has really great support. 80% of the top 10 architectural firms, as well as 65% of the top 20 in the US, as well as great support in Canada. Now the question becomes, how is the industry working to achieve some of these goals? One of the methods being used is to establish energy performance goals for new buildings. Let's begin with benchmark goals. One of the most specific and verifiable energy standards is going to be the total energy consumption. So it could be relative to code, which is great for new buildings, or relative to peer group, which is great for existing. Peer-based benchmarks are defined based on the percentile of the site energy use intensity. You may use the online laboratory benchmarking tool to compare your energy consumption with that of more than 800 campus facilities. Another increasingly common approach will be to certify with a rating organization, such as United States Green Buildings Council Leadership in Energy and Environmental Design, or LEED. Under LEED, certified design professionals will use a scoring system to assign points towards energy and atmospheric credit. I2SL has actually published a voluntary environmental performance criteria. This coordinates and extends LEED ratings to set the appropriate and specific recommendations for labs, as there is really no official LEED for labs. It can be used, however, as a reference. Now, LEED, Green Globes, Energy Star, or Green Guard certification may not always be the best fit for research facilities. Stakeholders really need to agree early on whether or not that certification is essential or if it should be surpassed. Now, if your customers opt out of such certification, don't give up on green design. Many opportunities exist without certification, and oftentimes it allows for new and innovative techniques to be applied or tried out. Using standards is another method, and there are a number of lab ventilation standards, all of which are very important. I will point out that this presentation does not focus on those, though they are very important. In fact, a pillar in our industry, Victor Newman, will be speaking specifically on fume hoods and the Green Lab, so stay tuned for his session at 2 p.m. ASHRAE IESNA 90.1's latest version assists engineers in designing efficient mechanical systems per the Chemical Hygiene Plan. Organizations that want to set more ambitious goals may set them at a percentage of the standard. For example, the United States federal government suggests energy performance goals at 30% below the latest ASHRAE IESNA 90.1. I will also point out that you have the opportunity to assess goals during construction, during occupancy, and at the end of its useful life. Simulations is another method and a simple approach using computer programs to simulate the energy performance through a building. It can be used to substantiate performance goals throughout the design and build. Because diverse process loads and ventilation rates make labs very hard to model accurately, I2SL has developed a lab modeling guideline using 90.1 Appendix G. It provides guidance in lab energy simulations. Commissioning is a more thorough approach which evaluates and measures the performance of all energy-consuming equipment before the building is occupied. It can be repeated throughout or at intervals. As a result of these industry-wide challenges, goals, and trends, we're seeing more customer examples come to life for net zero, certifications, and right-sizing equipment. We'll take a look at each. But before we do, I want to point out that you want to make sure first that you have not oversized your mechanical system in the first place. On this efficiency pyramid, we see the strategies on the lower tiers are more effective and they increase the benefits of the upper tiers. So before you jump right into renewable energy resources and concepts such as net zero, please be sure that you have not oversized your mechanical system up front. Let's discuss net zero. So if curbing greenhouse gas emissions is the goal, one method would be to work towards a zero net energy. This has slightly different definitions depending on the certifying body, though they all agree that a zero net energy building is an extremely energy efficient building that produces through renewable energy sources, ideally non-combustible, as much energy as it consumes. To achieve this goal, architects and engineers often have to set a target for energy use intensity. The question then becomes, how do labs operate relative to these goals? Let's take a look at an example. Carleton College opened their doors to a new integrated science center, joining a new Anderson Hall with existing facilities. They used the LEED system and worked towards a platinum level and designed the building to have a net zero impact on energy consumption. The project had many goals. They wanted to support research and integrated education. They wanted to enhance the strengths of the current facilities. They needed to be flexible and adaptable with spaces for long periods of construction, and they wanted to be sustainable. So after input from their chemistry department, their chemical hygiene officer, Carleton facilities, and the dean's office, Labconco worked with them to develop some solutions. Ducted hoods are one of the largest consumers of energy because they vent tempered air to the outside, meaning that HVAC systems have to work harder to keep up with the demand of the lab. Labconco hoods' efficiency helped to lower those costs when application requirements meant that ducted hoods could not be avoided. So they reduce energy consumption by over 40% compared to traditional fume hoods and as much as 15% over other high-efficiency fume hoods, with a third-party test rating to 0.000 parts per million of tracer gas detected outside the fume hood. They can result in a substantial amount of energy savings. In this case, they approximately saved $148,500 per year annually on energy savings. Labconco filtered fume hoods cut operating costs by using comprehensive carbon filtration from ERLab to remove the chemical vapors from the air and recirculate the clean air back into the lab. This means that they need zero makeup air costs. So for 11 filtered fume hoods in the space, they were able to save $110,814 annually on average in energy savings. Glassware washers may drastically reduce energy and personnel costs associated with hand washing. So with these parameters, per glassware washer, there was an approximate savings of $5,399 annually on energy at these parameters set. In the future, you can use the Labconco Glassware Calculator tool on our website to calculate your own potential savings. The end result was $270,111 of average annual energy savings for this facility. Next, we'll look at LEED 4.1, which is one example of an energy certification. It is the current version of LEED, which addresses energy efficiency, water conservation, site and material selection, daylighting, and waste reduction. Let's take a look at an example. So Lafayette College's Rockwell Integrated Science Center received a 2021 AIA Education Facility Design Award in the Excellence category. They were a LEED Gold facility designed to reduce energy consumption by 45% below the LEED baseline. This new facility positions Lafayette College as a leader in supporting education and research in the STEM fields as it joins their liberal arts and engineering to create a science hub serving nearly half of all of the students majoring in sciences. It is a living lab of sustainability as the college's first LEED Gold facility, with 8 biology teaching labs and 13 biology research labs. For 2 filtered fume hoods installed, they were able to save on average $20,148 in energy savings per year. Next, let's look at the trend called rightsizing. So rightsizing your equipment is by far the optimal strategy as it respects the principle of diversity, meaning that all equipment in a lab is unlikely to be operated at rated capacity simultaneously. Let's take a look at Children's Mercy Research Institute, a research facility servicing 367 hospital beds with 410,000 square feet of dedicated research space. They had many project goals. They wanted an integrated research hub. They wanted flexible lab spaces as they began construction before much of their research work was solidified. They needed comprehensive GMP suites for advanced gene and cell therapies. They wanted energy savings, including a building's mechanical ventilation system and lab equipment designed to provide the best possible safety at the lowest possible energy use. They additionally needed equipment that would be built to withstand the rigorous needs of researchers and optimize their workflows for the lab of the future. The solutions we were able to work with them to provide included a 56% in energy savings per CFM by switching from Type B2 biosafety cabinets to Labconco's exclusive Type C1. This meant that they needed a smaller mechanical ventilation system by volume, with lower static pressure requirements, and the dedicated exhaust system per B2 cabinet was no longer needed. This translated into a savings of $173,680 annually for the Type C1 biosafety cabinets exclusively from Labconco. Now, Labconco's exclusive fume hood with third-party test ratings of 0.000 parts per million tracer gas detected outside the hood were installed at 28 units, which translated into an energy savings annually of $140,000. So they were able to save annually $319,079 in annual energy savings, as well as feature solutions for the rest of their workflow with non-ventilation products and able to maximize the ultimate exhaust diversity calculation for the ventilation equipment in the space. With Labconco's potential mix ROI calculator, you can assess the ideal mix of ducted to ductless fume hoods in the space. So first you're going to ask yourself, will the chemical hygiene plan support the use of a filtered fume hood? If it will, you'll begin. If it won't, you'll install only ducted products. So if it does, you'll size the room. You'll enter your dimensions for width, depth, and height. In this common scenario, we've got a small to mid-sized lab at 30 feet by 30 feet by 10 feet. This auto-populates the lab volume in cubic feet at 9,000. You're going to look at your chemical hygiene plan and the design air changes per hour. In this case, for this one room, it is 6. So you're going to enter in 6. That means that you need to move 9,000 cubic feet of air 6 times per hour for this one lab. So this populates the required airflow volume for the ducted hoods in that lab scenario. You'll enter the manufacturer's specified CFM value, in this case 735, to populate the exact number of required hoods to keep that lab safe per their application and the chemical hygiene plan. In this case, they only require 1.22. The next row rounds up to ensure their safety. So in this scenario, we know that we need at least 2 ducted hoods to meet the chemical hygiene plan specifications. In the next common scenario, we've got a larger lab at 80 by 40 by 10. It auto-populates the lab volume in cubic feet at 32,000. The air changes per hour for this scenario is the same at 6. So you're going to enter in 6. That means that you need to move 32,000 cubic feet of air 6 times per hour for this one lab, populating your required airflow volume for the ducted hoods within that scenario. You're going to then enter the manufacturer's specified CFM value, in this case 690. That populates the exact number of required hoods to keep that lab safe. And in this case, it is 4.63. It's going to round it to 5 to keep the lab safe. So here we know that to keep this lab safe and meet the chemical hygiene plan, we need at least 5 ducted hoods. With these scenarios, you'll usually find that a 60-40 or 50-50 mix results in less capital costs and more annual energy savings costs per year. If you forego this assessment, simply opting for all filtered, you'll inevitably oversize your mechanical system in the first place, as well as not allow for flexibility in the future as research and application needs evolve. Other assessments to keep in mind will be energy assessments, and you'll want to factor in climate zones. So the energy cost savings vary drastically per your location. So let's say you're in California where it's 87 degrees outside. That's going to cost substantially less to temper that air than where I'm at in Kansas City where it's -2. So the cost for Kansas City is going to be much more. Additionally, you're going to want to specify sustainable materials and systems to benefit the lab interior's triple bottom line. That is to reduce the impact on the environment, enable a healthier workplace, and increase the cost effectiveness for the owner and recruit top talent. VAV systems reduce the volume of outside air that needs to be conditioned and save a substantial amount of energy. They can be used along with high efficiency equipment, direct drive, energy efficient blowers, and user behavior programs such as a Shut the Sash program, which is employed at some of the top universities in the country. So design professionals have the real challenge to develop the next generation of labs with energy optimization, renewable energy resources, as well as sustainable construction principles in mind. But for optimal ROI, they need to factor in comfort, health, and safety for a holistic approach. And remember that one size does not fit all. Stick to plan. Don't forget the chemical hygiene process and plan, and to go back to it, as the needs for a geological lab versus a gene and cell therapy lab versus a cannabis extraction lab over a general chemistry academic lab or a research facility. These applications vary drastically, and thus so do the ventilation requirements for the space. By following this process, you'll be better prepared to make decisions that meet your customer needs today without compromising future generations. Understanding the roles of all the various stakeholders in the process and how they integrate will be key for streamlining the planning process. Stay up to date on applicable standards, regulations, and sustainability trends to ensure that you are utilizing the best possible methods at the time. And lastly, specify the mechanical system and solutions that are the most ideal mix to reach the most sustainable system possible. Expert targets and research indicate that if half of all American laboratories can reduce their energy use by 30%, the nation could reduce its annual energy consumption by 84 trillion BTU. This is the equivalent to the energy consumed by 840,000 households. An improvement of this magnitude would save 1.25 billion annually, decrease carbon emissions by 19 million tons, equal to the environmental effects of removing 1.3 million cars from US highways, or preventing 56 million trees from being harvested. Thank you so much for this excellent discussion on sustainability. Our Sustainability Committee has made great efforts on sustainability initiatives, and it is a continuous process. Labconco's team is eager to keep this dialogue open. Please email us with feedback or questions at sustainability@labconco.com. We will additionally leave you a link to the resources we've discussed and look forward to answering your questions now.
Great. Thank you very much, Ryan, for that wonderful presentation. So as Ryan said, we are ready to move into the Q&A portion of this webinar, and I will make sure you have Labconco's contact information here. So a reminder for those of you who may have joined us late in the presentation, you can send in your questions or comments for Ryan by typing them into the Q&A box located on the right-hand side of your screen. The handouts tab is also on the right-hand side of your screen with some materials relevant to this presentation. The handouts tab also has information about Lab Manager's upcoming Live Leadership Summit in Baltimore, Maryland this May. Our special discounted early bird ticket rate ends on Friday, February 18th, and a ticket purchased by February 18th will also enter you into a special raffle to win a free Lab Manager Academy training course. So Ryan, thanks for a great presentation. Let's move right into the questions here. Ryan, the first question we have from our audience is, why do the dollar savings vary per installation example?
Yes, hi, welcome. Thank you. That's an excellent question. So several factors go into the savings, such as the type and number of each piece of equipment in the space, as well as the size of the room, the equipment options that were selected on the fume hoods and equipment such as a VAV mechanical system or auto sash closure. I will reiterate that every lab is going to be unique. So applications vary, and thus so do those application requirements and the requirements to keep that a safe environment for all workers. So what is optimal for all, or for one lab, is not going to be the same for all.
Okay, great. Thanks very much. Let's move on to the next question on the list here from the audience. It says, do you ever run into circumstances where individuals serve dual roles in the planning process?
Absolutely. Dual roles actually happen quite frequently, especially in the smaller organizations. However, the owner officer, architect, engineer, and manufacturer really need to all be on the same page, as I reiterated in the presentation. Ultimately, that building owner is going to make the final decision or delegate the decision to the architect or safety officer.
Great, thank you. Let's move on to the next question here. It says, who decides the diversity calculation for CFM? Is it the building owner or safety owner or both?
Similarly, the owner can hire whomever they want to assist them in making the correct decision. At the end of the day, however, though, it's going to be the owner's responsibility to keep those people in the building safe and ensure that they're not exposed to hazards in the workplace. The diversity factor decision follows the same path as all these other decisions. So first, they'll determine the potential for fume hood demand. The chemical hygiene officer should be responsible for coordinating a chemical hygiene committee to determine the highest potential for fume hood demand in the lab. They should apply a safety factor that is acceptable to the chemical hygiene officer. And in this way, they've determined the minimum safe demand for fume hood use. The lab planner then converts this to a maximum fume hood volumetric rate due to the fume hood demand. They'll multiply the fume hood required volumetric rate at the safe design condition times the number of hoods in use per the diversity factor. Then they'll add the minimum safe airflow of the hoods not in use times the number of hoods not in use. And this figure will represent the maximum safe airflow for fume hood demand. The mechanical engineer then takes the maximum safe airflow for fume hood air changes per hour, the maximum needed airflow to meet all the thermal conditioning requirements and the directional airflow requirements, and the maximum needed airflow to meet safe fume hood airflow demand, and determine the maximum required capacity of that mechanical system.
Okay, great, thank you. Here's another question from the audience. It says, who makes the final determination on the use of filtered hoods?
So again, it's going to begin with the safety officer exploring if the technology is really safe for their applications. It's not always going to be safe. So from there, the architect can direct the owner or the chemical hygiene officer to duct list for evaluation. But ultimately, it's going to be the decision of the owner / chemical hygiene officer to decide if it is going to be safe in that lab space. The design team can weigh all the other factors, though, to determine the maximum allowable ductless hood following those steps that I outlined in the presentation today. And it's a really collaborative process. But at the end of the day, if someone in the lab gets hurt, OSHA will fault the owner and the chemical hygiene officer. So that's important to keep in mind.
Great, thank you. I think we have one. Excuse me, I'm sorry, I apologize. I think we may have lost our questions. But I think that may be all we have time for. So again, I invite you, just if you have a question or a comment for Ryan, you can type them here and we will have a copy of your contact info, and Ryan may be able to get back to you offline if possible. But I think we've actually reached the end of our questions here.
Yeah, so, there's a couple of those that I'm going to follow up on just from a few of them, but otherwise, this is a great discussion and I really appreciate all of you.
Okay, wonderful. Thank you so much, Ryan. I appreciate it. So this does bring us to the end of this webinar. And again, I would like to remind you all this webinar will be available on demand shortly following this live presentation. So Lab Manager will email you once that video is available. You can also visit the Green Labs Summit website. It's at the bottom of your screen right now, summit.labmanager.com/greenlabs, and we will post the video there once it's available. So on behalf of Lab Manager, I'd like to thank Ryan Rios for all of the hard work she put into this presentation, and I would like to thank all of you for taking time out of your busy schedules to join us today. Once again, thank you to our sponsors, Labconco and Millipore Sigma, whose support allows Lab Manager to keep these webinars free of charge for our readers. Finally, I would like to invite all of you to attend the other webinars offered by Lab Manager's Green Labs Digital Summit. Our next presentation, Fume Hoods and the Green Lab, will take place in just a little while at 2 p.m. Eastern, and we invite you to please join us. For more information on all of our upcoming or on-demand webinars, or to learn more about the latest tools and technologies for the laboratory, please visit our website at labmanager.com. We hope you can join us again. Thank you again to Ryan, and thank you to all of you for being part of our Green Labs Digital Summit, and we hope you have a great day.